Okay, ladies and gentlemen, so last class we talked a little bit about uh, trigonometric identities. So we introduced trigonometric identities and we saw a few of them and we solved a few problems. We're going to be continuing with trigonometric identities. Specifically, I told you guys that we were going to look at some other trigonometric identities that we can derive from the Pythagorean identity. So the Pythagorean trigonometric identity is sine squared plus cosine squared is equal to 1. Like I mentioned before, if I subtract sine squared from both sides, I get a new version of the identity. Cosine squared theta is equal to 1 minus sine squared theta. Now here's what else you can do. If you use division over everything, so I'm going to take this whole equation and divide it by, in this case, sine squared. I get sine squared theta divided by sine squared theta, which is equal to 1. Cosine squared theta divided by sine squared theta, which is equal to cotangent, is equal to 1 sine squared theta. 1 over sine squared theta, which is equal to cosecant. So once again, you have to follow your rules. What you do to one side, you do to the other, which we did. But it gave us a completely new trigonometric identity. 1 plus cotangent squared theta is equal to cosecant squared theta. So let's go ahead and try to do this and get a different version of the identity. So we're going to take, subtract the sine theta from both sides. So they subtracted it from both sides. In this equation, we had cosine squared theta plus sine squared theta, and subtract from both sides, we get that, which we already had. And then here they divided all three terms by sine squared theta, which is what they did over here. Now we're going to do the opposite way. We're going to take everything. We're going to first subtract cosine from both sides. So we're going to get 1 minus cosine squared theta. And then we're going to divide all three terms by cosine squared theta. So we're going to take this whole thing divided by cosine squared theta, divided by cosine squared theta, divided by cosine squared theta. Sine over cosine squared theta gives you tangent squared theta is equal to 1 over cosine squared theta gives you secant squared theta minus cosine squared theta over cosine squared theta, 1. So here you have a new version of the identity. So if we were to simplify each expression using basic identities by substituting and then simplifying, and we want to write in terms of sine and cosine only whenever possible, let's go ahead and see what we can figure out. So if we have tangent theta times cosecant squared theta, that gives us, remember we want to put everything in terms of sine and cosine, so we're going to say sine over sine theta over cosine theta times 1 over, this is sine theta, times 1 over sine theta. Well, these signs are just going to end up canceling out. And what you're left with is 1 over cosine theta times sine theta, which is just equal to secant theta times cosecant theta. Let's try one that's a little bit harder. I'm going to flip to the back. Let's take a look at number 23. I like doing the first and last one for y'all. Now, keep in mind that when you're working with identities, you want to go ahead and apply all of your existing mathematical rules. So it might not always seem like you can just do everything willy-nilly, but once you really get a hang of it, you will be able to look at these and start to figure out exactly what they're asking you to do. For example, let's say I am working on this one right here, 23. We have sine squared theta over cosine theta plus cosine theta. Right? Now, in the beginning, it doesn't look like we can add these together right away. But what we can do is we can actually go ahead and make this into a fraction that we can add to this. Now, if I were to multiply this by cosine theta over cosine theta, I'm multiplying this by 1. So I'm not changing the value of it, right? This is still cosine, but now it's going to look a little bit different. I'm going to have sine squared theta divided by cosine theta plus cosine theta times cosine theta. That's cosine squared theta over cosine theta. See, if I were to cancel out one of the cosines, I would still go back to my original cosine theta instead of it being cosine squared over cosine. But this actually helps us because now that we have the same denominator, we can actually add these together. This gives me sine squared theta plus cosine squared theta all over cosine theta. That's an identity. In fact, that's the Pythagorean identity. This is simply equal to 1 over cosine theta. And what is 1 over cosine? That's just secant theta. This is a really neat trick that you guys should always remember. Whenever you're adding two fractions that really don't, or adding two trigonometric identities that really don't seem like they can be added, try multiplying them so that you have the same denominator. Once you have a common denominator, go ahead and add them together and see if you can come up with any identities that will help you simplify your fraction. Remember to always turn things into terms of sine and cosine, and to make sure that you combine as many terms as you can until you get it as simple as possible. See, from here, we went down to one simple trigonometric identity.